Hi, good morning students. So today's topic is 01 knapsack problem using dynamic programming. So here knapsack problem is classified into two ways. One is fractional knapsack problem that we already solved by using greedy method. So second one is 01 knapsack problem. So using dynamic programming we are going to solve this one. So here, what is the difference between greedy knapsack problem and 01 knapsack problem using dynamic programming? So this 01 knapsack problem is similar to fractional knapsack problem, but in this we may not consider the fraction of the object. Means, so whenever you want to place the object into the knapsack, you have to consider the full object, or you cannot keep it. So if you place the object fully, means that value is considered as 1. So if you are not interested to keep that object into the knapsack, okay, that value is considered as 0. So here the problem statement is given as, so generally it is given with n objects. So each weight of object weight is represented as wi, and profit of that wi object weight is given as pi. So the variable I value varies from 1 to n, and the knapsack with capacity capital M. So capacity of the knapsack is represented by capital M. Next, here the objective is we have to fill the bag with the help of n objects, and the resulting profit has to be maximum. So the profit should be maximized. So in that way, you have to keep the object into the knapsack. So here the problem can be stated as we need to maximize the profit. Okay, that is subject to the condition the sum of the weights always less than or equal to capacity of the knapsack. So here we are considering 01 knapsack problem. So here solution is given in the form of xi values. So here three objects are there. We need to consider I values as 0, 1. I values as 1, 2, 3, means 1 representing the first object, 2 representing the second object, 3 representing the third object. So here xi values belongs to means xi value is either 0 or 1. So xi is required to be 0 or 1. So if the object is placed into the knapsack, that xi value is considered as 1. If the object is rejected, means we are not keeping that object into the knapsack, that xi value is considered as 0. So based on this 0, 1 values, means we are keeping the object into the knapsack, or we are rejecting the object to keep into the knapsack. So based on that, this problem is called as 01 knapsack problem. So how to solve this 01 knapsack problem? So we are follow some steps. So here we are using the set approach. There are two approaches are there, but here we are going with the set approach. So let symbol s, okay, I is the power of s power I consists of pair of profits and weights. So here that is represented as p comma w. Okay, p is representing the profit and w is representing the weight of the object. So here in this tuple, the first value represents the profit and second value represents the weight. So initially set power 0, s power 0. So first set, so given with, so profit value as 0 and weight of the object is considered as 0. So then based on this s power 0, s power 1, so we are going to compute s power I plus 1. Okay, so that is nothing but merging of s power I and s1 power I. So by following this step 1 and step 2, so we are going to generate a sequence of decisions, and for those sets we are going to apply one formula. That formula is called as a purchasing rule. So here we are not using any mathematical formula, just we are using a purchasing rule. It is also called as dominance rules. So what do you mean by purchasing rule? So here consider set S power I plus 1 containing tuple P of Pi and Wi, and Pj consider set S power I plus 1 containing tuples, okay, Pj comma Wj and Pk comma Wk. So here the condition is Pj less than or equal to Pk and Wj greater than or equal to Wk. So then if these two conditions are satisfied, then we need to eliminate the tuple Pj comma Wj. So means, so in the set, so set is given with the tuples, they are given in the order. So in that we need to remove the tuple, okay, with less profit and more weight. So there we are going to apply the purchasing rule. So here now we are going to solve the problem, knapsack problem. So that is given as number of objects we are considering as 3, that is given as n value, n equal to 3, and profits as for those 3 objects P1, P2, P3 as 1, 2, 5, and weights are W1, W2, W3 equal to 2, 3, 4. So initially S power 0. So initial set we are finding out. So initially the tuple P comma W values are considered as 0 comma 0. So now we are going to generate so S1 power 0 set. So S1 power 0 means here we are considering the first object. Okay, what is the first object? So profit of the first object is 1. Profit of the weight of the first object is 2. So profit and weight we are considering. So those values are added to the tuple given in the S power 0. So now, so 0 plus 1, okay, 0 plus 2. Now if you add them, we are going to get the tuple 1 comma 2. So now we are going to generate S power 1 set. So S power 1 is nothing but union of S power 0 and S1 power 0, means we are merging this S power 0 and S1 power 0. So those values are 0 comma 0 and 1 comma 2. So now again we are going to generate a set. So S1 power 1. So means we are considering, now we are considering the second object. Profit of the second object is 2. Profit weight of the second object is 3. So these values, okay, means 2 and 3 are added to the tuples in the S power 1. So if you add them, we are going to generate the tuples 2 comma 3 and 3 comma 5. Now we are going to generate a set S power 2. So that is nothing but merging of S power 1 and S1 power 1. So that will result in the means, so S1 containing 2 tuples and S1 power 1 containing 2 tuples. Okay, those are written in the set S power 2. Now we are going to add the third object, that is containing profit P3 as 5 and weight W3 as 4. So those are added to S power 2 set. So if you add them, so 0 plus 5 and 0 plus 4 and 1 plus 5, 2 plus 4, 2 plus 5, 3 plus 4, 3 plus 5, 5 plus 4. So this will generate the tuples 5, 4, 6, 6, 7, 7, 8, 9. So now again, now we need to, S1 is generated, S power 1 is generated, S power 2 is generated. Now we are going to generate S power 3. So that comes with the merging of or union of S power 2 and S2 power 2. So this will generate the final list of tuples. So now we are going to consider s power 3. So those values are 0, 0, 1, 2, 2, 3, 3, 5, 5, 4, 6, 6, 7, 7, 8, 9. So now look at this. Here, first the capacity of the knapsack is given as 6, but if you consider these two tuples 7, 7, 8, 9, it containing weight values as 7 and 9. Okay, this is 7 is the weight of this tuple, and this tuple containing the weight 9. So these values are exceeding the capacity of the knapsack given in the problem. So these two tuples are get eliminated. So now resulting tuples are 0, 0, 1, 2, 2, 3, 3, 5, 5, 4, 6, 6. So then again check these tuple values. Okay, 0, 0, 1, 2, 2, 3, 3, 5, 5, 4, 6, 6. So now consider the tuples 3, 5 and 5, 4. Here profit is in the increasing order. If you consider the weights, the weight is given in a decreasing order, means violating the property. Okay, here we are going to apply the purging rule. So, or dominance rule. So, here 3 is Pj, 5 is Wj, 5 is Pk, 4 is Wk. So, means what is the condition of the purging rule? So, Pj always less than or equal to Pk, this is Wj greater than or equal to Wk. Then Pj, Wj tuple get eliminated. Okay, the purging rule is Pj means, so profit of this object always less than or equal to second object profit, and weight of the first object always greater than or equal to weight of the second object. So then the tuple, so Pj comma Wj get eliminated. So the resulting set is given as 0, 0, 1, 2, 2, 3, 5, 4 and 6, 6. So now we got the final set. Now we are going to find out the solution. So the capacity is given as 6. Now look at the tuple. Okay, this last tuple, so profit is 6. The weight is less than or equal to capacity of the knapsack. So 6, 6. So now we are considering this tuple and we are going to check that belongs to set s power 3. So here the tuple 6, 6 is in, or it is belongs to s power 3, and tuple 6, 6 doesn't belongs to s power 2. So means we need to set x3 value as 1, means, so this one is related to the third object. So means we need to keep the third object into the knapsack. So next, here we already kept this third object into the knapsack. Now we need to backtrack. We need to go with the previous set. So here we need to eliminate profit and weight values from this 6, 6. So now what we are doing, 6 minus 4, 6 minus 5 and 6 minus 4. So resulting in a tuple values 1, 2. Now check, this is belong to previous set, that is s power 2. So s, it is belongs to s power 2, and check, it is belongs to s power 1. So it is belongs to s power 1 also, means this value is comes from the set s power 1, and this value is copied into s power 2, means, so this value doesn't, so now x2 value we need to consider as 0. Then go for again check 1, 2 belongs to s power 1 and it belongs to s power 0. So in this case 1, 2 belongs to s power 1 and it doesn't belongs to s power 0. So then make x1 as 1. So here what we are doing is, so we are considering the sets s power 3, s power 2 and s power 1. So we are going with the tuple. First tuple is 6, 6 is belongs to s power 3 and we are checking it is belongs to s power 2. So it belongs to set s power 3 and it doesn't